Welcome to the lecture for ULab Physics and Astronomy's CS1 module. In this lecture, we're going to learn what a terminal is, how to use it, and some basic commands. So, we'll start off with what a terminal is. We're used to running commands through the graphical user interface on our computers already, which means you click on icons like the ones from Microsoft Word, and that opens up the program. When you're doing your own development, though, you'll have to go a bit lower level. So the interface you'll be using will look something like this. It may not have the colors. Yours may have, the time of day in a different place or some other information. It might have your username, but it'll look something like this. It'll have the basic feature of, it'll be a little thing where you can put in some text, some text over here. And what we can do with this is pretty much anything we could from the graphical interface. So we'll see how to do that in a bit. First of all, how you even get this. On a Mac, you can get this by opening up Terminal from the Spotlight search that you do if you hit Command and Space, which I don't think I can screen share. On a Windows computer, it's a bit more complicated, and you'll likely need to get something called git bash. We'll provide links to descriptions of how to do that. CS61A runs their students through a very similar setup process, so we'll likely have you follow the directions for that. Anyway, once you've reached your terminal, which is a fairly base level program and should be as easy to install for Windows users as anything else, and should be pre-installed for Mac users, you'll be greeted with this sort of interface with not very much on it. So what are some things you can do? The first command you can use is ls. This lists all the folders and files in the directory you're in. So the directory you're in is specified in my setup by this little bit of text in blue. It's just got the little tilde here, which means it's the top level directory. It's what you would get at the top in Finder or in File Explorer. So over here, we've got a bunch of my folders. You can see my documents folder, there's my music, my project and research, and so on. So let's say today we want to go into my projects folder. So the command for that is cd projects. CD moves you from place to place. And there's some more things you can do with it. If you just hit cd with no arguments, which means with no second word, it'll just take you back out to the top level. You can do, I'm going to go back into projects. I'm going to ls again, the same thing as we did before, but now it's going to show me the subfolders over here. And let's say I want to go into ULab. But first of all, I want to go back up to the top level so that I can show you a couple of things. First, moving one up from where I am is achieved by this cd double dot. That will move me from base, or base is the environment. It will move me from tilde / projects back up to just tilde, back up to root. And also what I can do with cd is move multiple folders at once. So I can do cd project / ulab. Great, so you can move around pretty much just as freely as you can with the graphical interface using these commands, cd and ls. So the next question is naturally, can I do all the things that I used to be able to do on the Finder? Like suppose I want to make new files, move them around. Yeah, there's functionality for all of that. So let's start off with how to make a folder or a directory. That's done with the mkdir command, mkdir ulab demo. So what that's done is it's made a new folder with the name ulab demo. So I can ls, and we see right here that that folder exists now where it didn't before. And I can cd into it, ls there, and it doesn't return anything because we haven't put anything inside it yet. So let's go back out to ULab and see if there's something I want to put inside it. Maybe I want to put this image, frequentist versus Bayesians .png, into the folder, this one over here. So what I would do then is use the mv command. mv, the thing that I want to move, frequentist versus Bayesians.png, which, by the way, that's an image that you'll see probably on a later assignment, and you'll find it hilarious if you haven't seen it already. Anyway, it moves frequencies versus Bayesians.png, which is just a normal image file, into ulab demo. And to check that this works, let's ls, and I see frequencies versus Bayesians.png is no longer here. And so if I want to confirm, I can also ls ulab demo, which will show me the files under ulab demo without moving me there. And it'll show that our move was successful. So now we know how to move files around, how to make directories, and we can also see how to make new files. Let's suppose I want to make a file called demo.txt. The command for that is touch. And I can ls and I show that it's there. And now I can open demo.txt. And that opens up a separate text editor. And so right now it's moved me off the screen share and it's taken me to my own text editor. So let's see if I can show you that. New share, and it's taken me to this text editor where I can write whatever I want. And this is just the same interface that you'd get from double-clicking a text file. In fact, we can pull up the parallel interface in the Finder. So if I screen share my Finder, which is over here, I can go into my projects folder. I can go into ULab. I can go into ULab demo, open up this text file, and that works the same as it did in the terminal. So you see that anything you can do in the terminal, you can do in the graphical interface. But the terminal has a lot more functionality that we'll find useful when we're developing our own code. Now that we're comfortable with using the basic commands on the terminal, let's get into some more advanced tools that we'll need for actually developing code. We're going to look at 3 tools today: Conda, pip, and Jupyter. What Conda does is it manages environments, which means if I've got 2 versions of a package that I need, version A and version B, then there's some ambiguity about when I do, for example, a Python import of that package, whether it's going to get version A or version B. Sometimes you want one, sometimes you want the other. And sometimes those 2 versions might contradict each other. How do you specify this? You specify it by introducing a Conda environment and doing all your work within that environment. So I can set up 2 environments, one with version A of the package, one with version B. And then there won't be any ambiguity. I'll always get the one that I want. That's a bit abstract. Let's look at concretely how we can get these things. So I'm going to show you the setup pages for the 3 tools that I just talked about. Anaconda setup is fairly straightforward, and you can see the instructions of how to do it here, just like you would install any other piece of software. Unfortunately, I can't demonstrate it for you because I've already got Anaconda myself. But like you see here, it just runs you through the usual package installation steps. And once you've got that, you can go into your terminal and you can run commands starting with Conda, C-O-N-D-A, like the last 5 letters in Anaconda. So let's do that. Let's take a look at that. So over here, we've got, a new terminal. And we're starting off in the base Conda environment. That's what this means over here in my setup of the terminal. It's specifying which Conda environment I'm in. So now I can run commands starting with Conda. And here you see the documentation for how to do that. Here's some things you can do. You can clean packages that you're not using, you can install packages, you can uninstall packages, run things, and so on. So right now, what we're interested in is creating a couple of new environments. So if I want to create an environment named ULab demo, I do that. And it's going to ask me quickly if I should proceed with adding the environment in the place that it wants to. I say yes. And here it tells me to activate this environment, do this. So let's do that. And now we're in the ulab demo environment. Nothing has changed about the functionality that we've got. You inherit all the functionality that you had in base. So I still get to CD and ls the same way that I could before, but now I get to manage where I'm allowed to do things. So let's install pip over here and then show how doing that in the environment helped us. But first of all, let's ask, what is pip? Pip is a tool that's used best in conjunction with Conda to manage package installation. If someone else wrote code and they want you to be able to run it, they'll usually make it pip installable, which means you can get their code and import it into Python without having to go to their GitHub page or their personal website or anything to get the code. It's just you run a single line in your terminal. Getting pip over here in the web page is actually a procedure we will not need to use because we're using Conda in conjunction with pip. So over here, you see this curl command, and you could run this in your terminal and run python get pip, but that doesn't work very well in conjunction with Conda. Instead, what we want to do is just say Conda install pip. Whoops, that is a typo. Conda install pip. And what I did there to interrupt that, because I realized I'd run the wrong command, is I hit Control-C, and it gave me a keyboard interrupt and didn't keep trying to install PIO. But with the correct spelling, we can do Conda install pip, and it's going to look for this package named pip, and it's going to get these subdependencies. I tell it to go ahead. And in just a minute, we'll see that we can pip install things. And while we're waiting on that, not very long, we can see how the environments help us. So for example, I can run pip over here, and it's just going to show me the list of things that I can do with pip, same as we did with Conda. So I can install, download, uninstall, and so on like that. And I can pip install a particular package if I'm interested in it. And crucially, this doesn't work in different environments now. Pip is specific to ulab demo and to any other environments where I've installed pip. If I go back out, Conda deactivate, and let's say for clarity here, I make a new environment, Conda create ulab demo 2. It's going to go through the same procedure once again, and I finally activate ulab demo 2. Now, if I run pip over here, it's not going to know about it because only ulab demo knows about pip. So that's how we can use environments to our advantage. You only have to install something that you think is, dangerous or will cause side effects later on down the line in the specific environment where you care about it. And it's good general practice to separate out your projects based on environments, because then you can look at exactly what your code needs to run and tell someone else you need this version of this package, that version of that package, and there's no ambiguity. Anyway, let's go back out, let's reactivate ulab demo instead. I think you didn't have to separately deactivate, but just for the sake of showing you again. And now we can start using pip. I'm going to pip install numpy. Numpy is a computing package that you're going to use later on in the 4th CS module. For now, it's just sufficient to know that it's a Python package that's out there. And so it's installed numpy 1.19.2. I can run Python 3, import numpy, and this should go ahead just fine. There we go. Whereas by contrast, if I picked a random name that didn't exist in this environment, I wouldn't be able to install it. So if I said import tip tilt, which is the name of one of my other projects. It's not going to know what I'm talking about. And if tip tilt were pip installable, and if I had installed it with pip install tip tilt, then that would go ahead. Right. So that's a bit on the utility of pip and how easy it is to use and how it can get you code that you need. So I'm going to quit out of this by hitting on my Mac Control D. The command may differ a little bit, or you can just type exit like that while you were still in Python to get back out from Python to terminal. Right, so that's two of the tools that we need. The third tool is Jupyter. So you'll see here that I actually launched the Python interpreter for the first time, and I didn't make a fuss about it. You do this by running the Python 3 command. You can also set it to just be Python. I think on Windows, it's just py, like py, but that doesn't work for me here. That's not really the most intuitive way to prototype code though, because you see I can only put in one line or a couple of lines at a time. And if I make a mistake, there's not really an easy way to go back and change it. We'll talk in a later video part of this lecture on integrated development environments to get around this. But one way, then the way we're going to use for CS modules 1, 2, and 3 is the Jupyter environment. Jupyter lets you make Python code in notebooks. What does that mean? Let's see. So first of all, I'm not entirely sure if my base has Jupyter or not. Looks like it doesn't. So let's pip install Jupyter. And it looks like even though I do not have Jupyter in this environment, some other environment had it. And so it's getting some information from here, Jupyter and Jupyter console. And it's getting a bunch of these things that we need to run these notebooks. There's a lot of them, and but you can see exactly what it's getting and from where. And now we're done. And so I can run the command Jupyter just to see what I can do with it. And it's going to give me this little guide on usage. It's going to say, I want some of these things, especially I want a subcommand. Generally, when you see these things with the double dashes, those are optional arguments. There are things that I can pass in, but I'm not required to. What I am required to do is pass in a subcommand. The only subcommand we're really going to need is notebook to launch a notebook. So let's launch Jupyter notebook. And now this is going to take me out to my browser. So I'll have to switch my screen sharing to show you what I'm seeing over there. So over here, we get the Jupyter Notebook interface with the little logo up here. Jupyter was actually invented at Berkeley by a professor who's still here, Fernando Perez, so that's very cool. And as one of the advantages of that is Jupyter Hub, or the Berkeley Data Hub, which we'll see in a minute. For now, let's look at local Jupyter, and then we'll look at the Data Hub where we'll be doing the assignments. So you see a view a little closer to the Finder or File Explorer over here of everything that we have to work with. In this interface, I can open up .py files, which we'll be using to code later on. But what I'd like to do here is start an IPyNB, IPython notebook. IPython is short for interactive Python. And so what I'm starting over here, when you see these files with .IPyNB, is start a notebook running Python interactively. So I'm going to open up this one on my base Conda environment, and this makes a new notebook. ULab, and let's name it ULab test notebook. And here I can do all the things that I would do in regular Python. I can assign variables, and I can ask for what they are. And because it's interactive, I don't have to hit print or anything. I can just put in a variable name and get out what it is. And these are things that you'll play around with more when you start working with these notebooks for your assignment, and the kinds of operations you can do. So I can do a plus b, and that should give me 5. A times b should give me 6. I can even do a times c, which should give me the string high twice. And you'll see more on the functionality of Python later on, but this is what a Jupyter Notebook can do. It can make it a little more intuitive to code. So for example, I also don't have the problem that I had in terminal Python of I can't go back and change things. If I want a to be 4, I can just go over here, change a to 4. I rerun this cell, a updates to 4. I rerun this one. I get 4 highs instead of 2. You don't have to do all of this on your local machine. As Berkeley students, we all get access to the Berkeley Data Hub. And so this is an external link that I've opened up rather than this internal link that's this localhost. It's this internal link, datahub.berkeley.edu. I'm sorry, it's the external link. And it's got the same interface. So over here too, I can start up a Python notebook and I can do all the same things. Works just exactly the same. Now, one thing that's often overlooked when using the Data Hub is you do also have a terminal here, similar to how you would have it on your own computer. And we'll be using that later on when we get packages from outside and try to use it in our notebooks on Data Hub. So you see, I can start a text file, I can open a folder, but the one we're interested in here is the terminal. And over here, you'll see this prompt is a little different than mine. It doesn't have a username and it doesn't have anything really. It doesn't have a conda environment because we don't have a concept of conda environments here, but I can still ls and I see all of my stuff. I can still cd into, do I have any repositories here? I can cd into LaTeX lectures, which is a personal project of mine, and see that it's got these things. And so this terminal works exactly the same way that yours would. And so these are going to be really useful tools going forward when we start actually coding. Jupyter Notebooks are a great tool for coding, but they're not perfect and definitely shouldn't be used in every situation. We're going to be using Jupyter Notebooks for the first 3 CS assignments this semester, but then in the 4th, we'll do a shift towards working in what's called an Integrated Development Environment, IDE. And that's an abbreviation that you'll see a lot in computer science. The problem with Jupyter Notebooks is really that they don't stand up very well to complexity. Like we saw in the last video, you can run one cell after another and have it keep updating, which is fine if you're just doing a quick demonstration of an idea, or if you're calling functions that were written somewhere else. But it's not so great when you've got 500 different functions and you have to run all of the cells above it just to get the result you're after. Instead, the better way to code is in what's basically a text editor, like Notepad, except with some features that make it nice for coding, and for coding in Python specifically, or with whatever language you're interested in working with. So this is going to be just a quick demonstration of how to use the integrated development environment that I use, which is Visual Studio Code. Other people have different preferences. Common ones are Atom and Sublime Text, but I use VS Code. And there's a few reasons for that I will show you in a minute. So we're going to start off by opening the repository we're interested in, which in this case is in my projects, ulab demo, the folder we opened up earlier, and I'm going to open up this folder. And so over here, you start off with, on the left, we've got a list of the files we've already got here, the things that we created when we made this folder in the first video. And at the top, I can create a terminal to go alongside. So I've got this terminal just on the bottom to help me out. So over here, let's see what's in here. It's things that we see there. I'm going to touch starter.py, which is just going to be a Python file where I can write some code in. And then here I can, start running code as I want to. It's also good practice to activate the Conda environment that I'm interested in, and VS Code is going to remember the Conda environment that I'm in. And just to be sure, let's make sure it's using it over here on the bottom left. So then I can import numpy as np. Another thing I want to do is install matplotlib. I'm not sure if I have this on base. I do not. So this is another package that I'm going to install just for the fun of being able to visualize something. This is matplotlib, which is essentially carrying over some nice features for making plots and graphs from MATLAB. So now that I've got that, I can import matplotlib.pyplot as plt. And you don't have to worry about the specific syntax of that, but let's now use these to write something that's fun to look at. So for example, I might say A is np.random.normal 0, 100, 0, 1, 100. plt.scatter A0, and I'm just making something up that seems fun to me. So this is just a very simple thing that'll generate some random numbers according to this distribution, the standard normal distribution. You don't have to worry too much about the details, and plot it. And now the way I run this is I go down to my integrated terminal over here, and I can run python3 starter.py. Note that to do this, I have to be in the same directory starter.py, which means if I do ls right now, I'll see starter.py. Otherwise, if it were start.py and that's not found, it'll just get confused. So I run starter.py. And so in a second, you see that this shows up, and it shows up in a different window that I'll have to share separately. But you see the plot looks like that. And if I ran it again, I get a different result, but that's not the point. The big idea here is I can write code in this integrated development environment, and it's going to run just the same as in a Jupyter Notebook, except it stands up to complexity a lot better. You'll also notice the syntax highlighting that the keywords like import and as are in purple. If I write some things like for and while and in, those are also going to show up as purple to show that they're keywords. They're important things that you'll learn the meaning of later. And numbers are highlighted as well. And so it's just a lot visually nicer to look at than it would be if you were just on Notepad. Then there's additional features in VS Code that I like Git tracking that we don't have to worry about for now. And it also automatically reminds you which Conda environment are you in. And there's additional features and plugins that I can use, like linting, which means automatic bug detection. And all of these things are integrated into VS Code, and they'll be integrated into Atom as well if you choose to use that. There's packages you can get for Atom, and I believe also for Sublime Text. So using an IDE can be a really good choice once you've got a project that's too complex to be in a single Jupyter Notebook, which hopefully you'll see in your project groups, and you'll definitely see in real life research. For our final topic today, we're going to open up a Jupyter Notebook and look at some of the basic functionality you're going to be using in this week's assignment. So let's share my screen. And here we are in a blank Jupyter Notebook, just like I showed you before. So the first basic level of Python's functionality is that it can act as a fancy calculator. Anything that I can tell a calculator to do, I can tell Python to do. So I can do expressions like 1 + 1, and that'll give me 2. I can also assign variables. I can say A is 2, I can say B is 3, and I can ask for A + B later on. I can ask for A times B. I can do subtraction and division as well. And there's a couple operations built on top of this, one of which is the modulo operator, which is if I did this division and I only wanted an integer out, what would be the remainder? In this case, it's 2, because 2 divided by 3 is just 2. Just has a remainder of 2, rather. And I can ask for the quotient, the integer part of that quotient, and that'll be 0. I can also do this in reverse, of course, and that'll give me floor division of 1. Floor division is the term for when I only want an integer out. And I can get the remainder of 1 as well. So you get basic calculator functionality. In this, we also see that Python knows when something's an integer and when something is what we call a floating point variable, meaning it's a decimal. So in particular, I can ask for the type of a variable. The type of A is int. The type of A divided by B is float, because as we saw earlier, A divided by B is 0.666 recurring, and that's not a pure integer. Other examples of data types are the string and the Boolean. There's many others, and you can define your own data types, but these four, int, float, string, and bool, are the basic ones that we're going to be working with. Of course, Python has a lot more functionality than just a calculator. Otherwise, it wouldn't really be much use to us. So one of the first things you'll find is this sort of calculator functionality can extend to things like strings as well. I can do hi plus by. I get both of them put together. I can even do multiplication of strings. So I ask for hi times 3, I get hi 3 times, like I would expect. This is actually a rather unique feature of Python, where there is dynamic typing, meaning a variable is not tied for its entire lifetime to being the type that it was at the start. Just because A is an integer doesn't mean I can't make it a string later. So right now I can print A, then I set A to a string, and then I ask it to print A again. A was earlier an int, now it's a test string. This is a really interesting feature of the language. On the one hand, it makes it really flexible and really easy for you to put your thoughts directly into code. On the other, it can lead to some unexpected bugs and behavior you weren't necessarily anticipating. There are tools that we'll cover in later CS modules for dealing with that. Returning to Jupyter functionality for a moment, suppose I decide I don't want any of this output, I want to restore it all to what it was like before. I can ask to restart and clear output. Of course, what that means is now if I ask it for what A is, it's going to give me an error. It doesn't know what A is because it hasn't seen the line A equals 2 up here. So suppose I wanted to go through and rerun everything. I've got this button here that does restart and run all. I can just tell it to do that. It'll bring me back up to speed. Right. Another interesting feature in Python is lists. If I've got several variables that I care about, but I don't want to give them all individual names, I can put them in a list. So here's just a really simple one, 1, 2, 3, 4, 5. And then I can ask for a specific element of that list. So I can ask for the third element. Note that they start indexing at 0. So this is actually not going to return 3, but rather it returns 4. So 1 is the 0th element, 2 is the first element, 3 is the second element, 4 is the third element, and that's why you get a 4 over here when you ask for the third. Unlike some other languages, there's nothing that says all these things in the list have to be the same type. I can have it saying test string 3, 5 divided by 2 to be a float, and that's totally fine. That runs, and I can ask for the 0th element, and that'll be a string, and I can even check its type. It's a string. That one's an int. That one's a float. There's no inconsistency there, but that means you as the programmer have to be very careful that pretty much you know what you're doing. There are some cases where it's justified to do things like this, but you run the risk of confusing someone who's going to read your code. Python is very flexible, but it's almost too flexible sometimes. And so you'll learn to be sort of careful with these things. In fact, taking this concept even further, there's nothing that says an element of a list can't itself be a list. And this is really useful for defining things like matrices and arrays, although we'll see better tools for that later. So if over here, I put in a fourth element, or an element at index 3, the fourth element, and I say this is 752, picking some random numbers, and now I ask for the type of the third element. But I didn't rerun this cell, so it doesn't know yet, and now I rerun it. I ask for the type here, it's a list. If it's a list, I should be able to get some elements of it, 3, 0. And so the index notation sort of cascades. This thing that I've highlighted is a list. So I can ask for the type of its first element, which is going to be in here at 7. Right. And on the assignment, you're going to see a lot of these concepts of data types and variables and how to manipulate them and how to get calculation results that we might want. Okay. That's all for today. Good luck with completing the assignment, and I'll be at office hours in the usual Tuesday lecture time if you have any questions.